Okay, let's unpack this. Have you ever looked at a coding problem and just felt a bit stuck? Like, you know the language, but getting from the problem to a working solution feels
Yeah.
tricky.
Oh, absolutely. That's a super common feeling. And what we're seeing is that these challenges, they might seem unique at first glance, but they often fall into like predictable types.
Ah, so categories.
Exactly. And knowing these categories, plus having a solid approach, well, that's kind of a shortcut, really. It helps you become a better coder faster.
So it's not just random knowledge. It's about spotting patterns and having a plan.
Precisely. Like you see problems crop up again and again around certain areas. Take arrays, for instance,
Right.
sorting them, searching through them efficiently, finding duplicates, maybe rearranging things. It's all about how you handle that structured data.
Okay, arrays are definitely fundamental. What about like text?
Yeah.
String problems.
Yeah, string manipulation is huge too.
Yeah.
Things like reversing a sentence or checking if something's a palindrome, like, same forwards and back. Or maybe analyzing characters. Often it boils down to looping through the text and applying some logic step by step.
Makes sense. And it goes beyond just simple arrays and strings, right?
Yeah.
More complex data.
Definitely. Handling objects is crucial. Maybe merging data from different places or creating proper deep copies, so changing the copy doesn't accidentally change the original. That trips people up sometimes.
I can see that. And I know recursion and backtracking often appear. They can feel a bit abstract.
They can, yeah. But they're really powerful for problems where you need to explore different possibilities. Think about finding paths in, like a tree structure or a graph.
Or generating combinations.
Exactly, or permutations. It's a different way of thinking, sort of looping back on itself, but essential for those kinds of tasks.
And for modern web stuff, asynchronous operations seem unavoidable.
Oh, totally. Promises, async await, they're everywhere. You might get problems needing you to fetch data, maybe manage timing, make sure things happen in the right order, or deal with functions firing too often, like with debounce.
Right, managing those asynchronous flows.
And really, underneath a lot of this is just having a good handle on the basic data structures themselves.
You mean like stacks and queues?
Yeah, exactly. Knowing when to use a stack, last in, first out versus a queue, which is first in, first out, or linked lists, trees, especially binary search trees for ordered stuff, and hash tables or maps for like really fast lookups.
Having the right tool for the job.
That's it. Knowing these gives you the building blocks.
Okay, this is where it gets really practical, I think. Knowing the types is one thing, but the source is really stress. Having a process, right? A system.
Yes, a step-by-step approach. It turns that daunting feeling into something manageable. Step one, and this is critical, understand the problem.
Don't just jump in.
No, absolutely not. Read it carefully, ask questions, even if just to yourself. What are the inputs? What output do I need? Any constraints? Try saying it back in your own words.
Make sure you're solving the right problem. Right, then what?
Then, brainstorm solutions. Don't just latch on to the first idea. Think broader, maybe a simple brute force way first. Then consider if there are smarter, maybe more efficient ways. Think about edge cases early on.
Explore the options first.
Got it. Third step, choose an approach and plan. Pick the one that seems best, but before you code, sketch it out. Pseudocode is great for this, or a quick diagram, just outline your logic.
Plan the work, then work the plan.
Exactly. Then, step 4, you code it. Write clean code, use names for variables that actually mean something, make it readable.
And then, the crucial bit.
Step 5, test. Seriously, test your code. Simple examples first. Then hit those tricky edge cases you thought about: empty lists, null inputs, really big numbers. Does it break?
Find the bugs before they find you.
Right. And finally, step 6, if it matters or you have time, optimize. Look at your working code. Can it be faster? Does it use too much memory? This often comes after you know it actually works correctly.
Okay, so putting it all together, knowing these common problem types, arrays, strings, recursion, async, all that, and then applying this structured approach step by step. It's not just for interviews, is it?
Not at all. It's about building confidence, writing code that's more robust, more efficient in your actual day-to-day work. It makes complex tasks feel less chaotic.
It gives you a framework, a way to navigate the complexity.
Yeah, like having a map instead of wandering lost.
So that makes me wonder if this kind of structured thinking, breaking things down step by step, works so well for solving tricky coding problems. How else could you apply that same systematic approach to other complex challenges you face, maybe even things completely outside of programming?
That's definitely something to ponder.